大家好，欢迎回到一凡投资心得。特斯拉在10月22日发布了2025年 Q3 财报，数据又炸裂了。我会先介绍 Q3 财报最关键的数据，财报发布之后的 Q&A 环节，我会提取最核心的内容，用中英文双语字幕的形式呈现给大家。财报数据方面，总收入281亿美元，增长12%，但利润有点压力。毛利率18%，比去年低了1.8%，因为 AI 研发和重组费用猛增。经营利润16亿，下降40%。不过，自由现金流大涨46%，达到了39.9亿美元，现金储备更是暴增到了416亿美元。特斯拉的钱包比以往任何时候都更鼓，投资 AI 和产能完全不慌。汽车业务 Q3 交付49.7万辆，同比增长7%，创历史新高。Model Y 和 Model 3占了大头，交付48.1万辆，中国、韩国和欧洲市场尤为火爆。Model Y 甚至称霸挪威和瑞士，库存降到10天，说明需求超旺。不过生产略降5%， 44.7万辆，主要是工厂优化和关税影响。好消息是，特斯拉在美国推出了更便宜的 Model 3和 Model Y 标准版，续航超300英里，起价只要3.7万美元。Cybercab 无人驾驶 Taxi 也在加州测试，未来赶拉满。能源业务是本季度黑马 ，Q3 部署12.5 GWh电池存储，暴涨81%。Megapack 和 Powerwall 需求爆棚。毛利创纪录达到11亿美元。特斯拉还宣布休斯顿新的Megafactory明年投产，年产能达到50吉瓦时。AI 方面 ，FSD 版本14监督版10月上线，累计行驶超过60亿英里。Robotaxi 功能更智能，美国和欧洲多地计划推广。关于未来展望，特斯拉继续押注 AI 和能源。Cybercab Tesla Semi 和 Megapack 3都计划明年量产，还有 Optimus 机器人生产线也开始安装，2026年量产可期。Elon Musk 说，规模和 AI 会让我们领先同行。
Good afternoon, everyone, and welcome to Tesla's third quarter 2025 Q&A webcast. My name is Travis Axelrod, Head of Investor Relations, and I'm joined today by Elon Musk, Vaibhav Taneja, and a number of other executives. Before we jump into Q&A, Elon has some opening remarks. Elon?
Thank you. We're at a critical inflection point for Tesla and our strategy going forward as we bring AI into the real world. I think it's important to emphasize that Tesla really is the leader in real-world AI. No one can do what we can do with real-world AI. I have pretty good insight into AI in general. I think that Tesla has the highest intelligence density of any AI out there in the car, and that is only going to get better. And we're really just at the beginning of scaling at a quite massively full self-driving and Robotaxi, and fundamentally changing the nature of transport. I think people just don't quite appreciate the degree to which this will take off. Where it's honestly going to be like a shockwave. So it's a because the cars are all out there. We have millions of cars out there that, with a software update, become full self-driving cars, and we're making a couple million a year, and in fact, with the advent of with what we see now as a clarity on achieving full self-driving, unsupervised full self-driving, I should say, I feel confident in expanding Tesla's production. So that is our intent, to expand as quickly as we can our future production. So I was reticent to do that until we had clarity on achieving unsupervised full self-driving. But at this point, I feel like we've got clarity, and it makes sense to expand production as fast as we reasonably can. We're also making huge impact on the energy sector with battery storage. So with both the Powerwall and especially with the Megapack, we are dramatically improving the ability to generate more energy from the grid. So let me sort of talk a little bit about that, which is if you look at total U.S. energy capability, for example, there's roughly a terawatt of continuous power available in the U.S., but the average usage over a 24-hour cycle is only half a terawatt because of the big difference between day and night usage. If you buffer the energy with batteries, you can effectively double the energy output of the United States just with batteries building no incremental power plants. And it's very difficult to build power plants. So they take a long time. There's a lot of permitting, and it's not an industry that's used to moving fast. So we see the potential there for Tesla battery packs to greatly improve the energy output per year for any given grid, US or otherwise.
Q3 was a special quarter at multiple levels. We set new records not just for deliveries and deployments, but also around a range of financial metrics from total revenues, energy gross profit, energy margins to free cash flow. This was the result of continued confidence of our customers in our products and the relentless efforts by the Tesla team. The strength in deliveries was attributed to strong performance across all regions. Greater China and APAC were up sequentially 33 and 29% respectively. North America was up 28%, while EMEA was up 25%. The pace in deliveries was the function of continued excitement around the new Model Y. We had previously talked about 2025 being the year of the Y, and have since delivered on that promise with the new Model Y released in Q1, followed by Model Y long wheelbase and performance, and more recently, Standard Y in North America and EMEA. We're now operating a Robotaxi in 2 markets, Austin and most Bay Area cities. We've already expanded our coverage area in Austin 3 times since the initial launch and are on pace to continue expanding further. Unlike our competitors, our Robotaxi fleet blends in the markets we operate in since they don't have extra sensor sets or peripherals which make them stick out. This is an underappreciated aspect of our current vehicle offerings, which are all designed for autonomous driving. We feel that as people experience the supervised FSD at scale, the demand for our vehicles, like Elon said, would increase significantly. On the FSD adoption front, we've continued to see decent progress. However, note that total paid FSD customer base is still small, around 12% of our current fleet. We're working with regulators in places like China and EMEA to obtain approvals so that we can get FSD in those regions as well. Now, covering a little bit on the financial side, automotive revenues increased 29% sequentially in line with the growth in deliveries. While regulatory credits declined sequentially, we entered into new contracts and continued delivery on previously entered contracts. Our automotive margins, excluding credits, increased marginally from 15% to 15.4%, which was attributed to improvements in material cost and better fixed cost absorption due to higher volumes. The energy storage business continued to deliver with record deployments, gross profit, and margins. As discussed before, this business has a bigger impact from tariffs as measured by percentage of COGS, since currently all cells procured are from China, while we're still working on other alternatives. However, as the ramp of Megafactory Shanghai is happening, this is helping us avoid tariffs because we are using this factory to supply the non-US demand. Like Elon said, grid scale storage the only way we can get to electricity fastest is by using storage. The other thing to keep in mind is we are seeing headwinds in this business given the increase in competition and tariffs. The total tariff impacts for Q3 for both businesses was in excess of $400 million, generally split evenly between them.
We are expecting to have no safety drivers in at least large parts of Austin by the end of this year. So within a few months, we expect to have no safety drivers at all, at least in parts of Austin. We're obviously being very cautious about the deployment. So our goal is to be actually paranoid about deployment because obviously even one accident will be front page headline news worldwide. So it's better for us to take a cautious approach here. But we do expect to have no safety drivers in the car in Austin within a few months. I think that's perhaps the most important data point. And then we do expect to be operating Robotaxi in, I think, about 8 to 10 metro areas by the end of the year. It depends on various regulatory approvals. But you can actually, I think most of our regulatory applications are online. You can kind of see them because they're public information. But we expect to be operating in Nevada and Florida and Arizona by the end of the year. Ashok?
Yeah, we continue to operate our fleet in Austin without anyone in the driver's seat. And we have covered more than 250,000 miles with that. And then in the Bay Area, where we still have a person in the driver's seat because of the regulations, we crossed more than 1 million miles. And we continue to see that the fleet, Robotaxi fleet, works really well. Customers are really happy, and there's no notable issues. On the customer side, customers have used FSD Supervised for a total of 6 billion miles as of yesterday. So that's like a big milestone. And overall, the safety continues to be very good. And as Elon mentioned, we are on track to remove the person from inside the car altogether, starting with Austin.
Like the single biggest expansion in production will be the Cybercab, which starts production in Q2 next year. That's really a vehicle that's optimized for full autonomy. It, in fact, does not have a steering wheel or pedals, and is really an engineering optimization on minimizing cost per mile, like fully considered cost per mile of operation. So that's for our other vehicles, they still have a little bit of the horseless carriage thing going on, where obviously if you've got steering wheels and pedals and you're designing a car that people might want to go do fast acceleration and tight cornering, like high performance cars, then you're going to design a different car than one that is optimized for a comfortable ride, but doesn't expect to go past sort of 85 or 90 miles an hour, and it's just aiming for a gentle ride the whole time. That's what Cybercab is. So it's. Do I think we'll sacrifice margins? I don't think so. I think the demand will be pretty nutty. Like here's the killer app. Really, what it comes down to is can you text while you're in the car? And if you tell someone yes, the car is now so good, you can be on your phone and text the entire time while you're in the car. It's anyone who can buy the car will buy the car. And a story. We're also on the cusp of something really tremendous with Optimus, which I think is likely to be, or has potential to be, the biggest product of all time. And it's a difficult project, and it's worth noting that it's not like it's just automatic. I'm unaware of any robot program by Ford or GM or any of our U.S. sort of car companies. People I think maybe think of Tesla as a car company. We mostly make cars, and battery packs. So it's not just like an obvious fall off a log thing to make Optimus, but we do have the ingredients of real world AI and exceptional electrical and mechanical engineering capabilities and the ability to scale production, which I don't think anyone else has all of those ingredients. And we look forward to unveiling Optimus V3, probably in Q1. I think it'll be ready for to show off, and that I think is going to be quite remarkable. It won't even seem like a robot. It'll seem like a person in a robot suit, which is kind of how we started off with Optimus. But it'll seem so real that you'll need to like poke it, I think, to believe that it's actually a robot. And obviously, like the real world intelligence we've developed for the car, most of that transfers to Optimus. So it's a very good starting point. In conclusion, we're excited about the updated mission of Tesla, which is sustainable abundance. So going beyond sustainable energy to say sustainable abundance is the mission, where we believe with Optimus and self-driving that you can actually create a world where there is no poverty, where everyone has access to the finest medical care. Optimus will be an incredible surgeon, for example. And imagine if everyone had access to an incredible surgeon. So I think there's, of course we make sure Optimus is safe and everything, but I do think we're headed for a world of sustainable abundance, and that I'm excited to work with the Tesla team to make that happen. Yeah, I mean, bringing Optimus to market is an incredibly difficult task. To be clear, it's not like some walk in the park. At some point, I mean, actually, technically, Optimus can walk in the park right now. We do have Optimus robots that walk around our offices at our engineering headquarters in Palo Alto, California, basically 24 hours a day, 7 days a week. So any visitors that come by, you actually you can stop one of the Optimus robots and ask it to take you somewhere, and it'll literally take you to that meeting room or that location in the building. So I don't want to downplay the difficulty of Optimus. It's an incredibly difficult thing, especially it's difficult to create a hand that is as dexterous and capable as the human hand, which is the human hand is an incredible thing. That the more you study the human hand, the more incredible you realize the human hand is, and why you need 4 fingers and a thumb, why the fingers have certain degrees of freedom, why the various muscles are of different strengths, the fingers are of different lengths, and it turns out actually that those are all there for a reason, and so making the hand and forearm, because most of the actuator, just like the human hand, the muscles that control your hand are actually primarily in your forearm. The Optimus hand and forearm is an incredibly difficult engineering challenge. I'd say it's more difficult than the rest from an electromechanical standpoint. The forearm and hand is more difficult than the entire rest of the robot. But really, in order to have a useful generalized robot, you do need this. You do need an incredible hand, and then you need the real world AI, and you need to be able to scale up that production to have it be relevant, because it's not relevant if it's just a few hundred robots. But so you need to be able to make Optimus robots at volumes comparable to vehicles, if not significantly higher. So if you're trying to make 1 million of something per year, trying to make 1 million Optimus robots per year, that manufacturing challenge is immense, considering that the supply chain doesn't exist. So with cars, you've got an existing supply chain. With computers, you've got an existing supply chain. With a humanoid robot, there is no supply chain. So in order to manufacture that, Tesla actually has to be very vertically integrated and manufacture very deep into the supply chain, manufacture the parts internally, because there just is no supply chain. So this is the kind of thing where I'm like, if I put myself in the position of a startup trying to make a humanoid robot, I'm like, I don't know how to do it without an immense amount of manufacturing technology. So that's why I think like Tesla's in some almost a unique, I think unique position when you consider manufacturing technology scaling, real world AI, and a truly dexterous hand. Those are generally the things that are missing when you read about other robots, that they just don't have those three things. So no, I think we can achieve all those things, those three things, with an immense amount of work, and that is the game plan. So my fundamental concern with regard to how much voting control I have in Tesla is, if I go ahead and build this enormous robot army, can I just be ousted at some point in the future? That's my biggest concern. That is really the only thing I'm trying to address with this. So it's called compensation, but it's not like I'm going to go spend the money. It's just, if we build this robot army, do I have at least a strong influence over that robot army? Not control, but a strong influence. That's what it comes down to in a nutshell. Like, I don't feel comfortable building that robot army if I don't have at least a strong influence. First of all, I have nothing but great things to say about Samsung. They're an amazing company, and Samsung, it is worth noting, does manufacture our AI4 computer and does a great job doing that. So now with the AI5, and here's I need to make a point of clarification relative to some comments I've made publicly before, which is we're actually going to focus both TSMC and Samsung initially on AI5. So the AI5 chip design by Tesla is, I think it's an amazing design. I have spent almost every weekend for the last few months with the chip design team working on AI5. And I don't hand out praise easily, but I have to say that I think the Tesla chip team is really designing an incredible chip here. This is, by some metrics, the AI5 chip will be 40 times better than the AI4 chip. Not 40%, 40 times. Because we have a detailed understanding of the entire software and hardware stack. So we're designing the hardware to address all of the pain points in software. So I don't think there really isn't anyone that's doing this, the entire stack, all the way through real world, calibrating against the real world where you've got cars and robots in real world. That, like, we know what the chip needs to do, and we know what, just as importantly, we know what the chip doesn't need to do. To sort of give you some examples here, with the AI5, we deleted the legacy GPU or the traditional GPU, which is it's in AI4, but AI5 does not have. We just deleted the legacy GPU because it basically is a GPU. So we also deleted the image signal processor, and there's like a long list of deletions that are very important. as a result of these deletions, we can actually fit AI5 in a half reticle, and with good margin for the traces from the memory to the trip, the Tesla trip accelerators, the ARM CPU cores, and the PCI X the PCI blocks. So this is a beautiful chip. I've poured so much life energy into this chip personally, and I'm confident this is going to be a winner, next level. So it makes sense to have both Samsung and TSMC focus on AI5. And so even like technically the Samsung fab has slightly more advanced equipment than the TSMC fab. These will both be made in the U.S. In one TSMC in Arizona, Samsung in Texas, but it's we're going to make, starting off, just to be confident of having our goal, explicit goal, is to have an oversupply of AI5 chips. Because if we have too many AI5 chips for the cars and robots, we can always put them in the data center. So we already use AI4 for training in our data center. So we use a combination of AI4 and NVIDIA hardware. We're not about to replace NVIDIA, to be clear, but we do use both in combination, AI4 and NVIDIA hardware. And the AI5 excess production we can always put in our data centers. NVIDIA keeps improving. The challenge that they have is that they've got to satisfy a large range, a lot of requirements from a lot of customers. But Tesla only has to satisfy requirements from one customer. That's Tesla. That makes the design job radically easier, and means we can delete a lot of complexity from the chip. I can't emphasize how important this is. So like when you look at the various logic blocks in the chip, as you increase the number of logic blocks, you also increase the interconnections between the logic blocks. So you can think of it like just highways. Like how many highways do you need to connect the various parts of the chip? And especially if you're not sure how much data is going to go between each logic block on the chip, then you kind of end up having giant highways going all over the place. It becomes an almost impossibly difficult design problem, and NVIDIA's done an amazing job of dealing with almost an impossibly difficult set of requirements. But in our case, we're going for radical simplicity, and the net effect is that I think AI5 will be the best performance per watt, maybe by a factor of 2 or 3, and the best performance per dollar for AI, maybe by a factor of 10. So, that's, we'll have to, the proof's in the pudding. So obviously we need to actually get this chip made and made at scale. But that's what it looks like.